All right, everyone. Let's get started. Today we are going to actually see how the whole condition thing works in assembly. Like with condition, I mean if, else. Then there's the loops such as like while loop, do while loop, and for loop. So today's focus is going to be mostly on the conditions, like conditionals in assembly and how to deal with that, like how to understand how they are done. We will also look at something called reverse engineering. So basically looking at the assembly language, we are going to try to turn it into a equivalent C language, and which helps you a lot. Reverse engineering is one of the like well-known methods of like what we call traditionally hacking, because based on that we actually figure out what the source code was and we change it based on that, and then we like basically change it in our own way. And that's a very fundamental knowledge you need to know as a C programmer, or like a programmer who works on a very low level. So yeah, let's get started. So for our comparing, so with comparing, we mean that whenever we are doing some sort of statement like if a greater than b, and this is one sort of comparing. So to do any sort of comparing like this, we use something called CMP, and L is basically the long, the length of the data you are using. So the compare instruction facilitates the comparison of operands. So whenever we do compare right top, left top, the instruction performs a subtraction of its operands, discarding the result. So it doesn't care what the result is. All it needs is to get a subtraction of left top and right top. The instruction sets flag in the machine status word register EFLAGS that records the result of the comparison. So it doesn't care what the result is. It just cares about what sort of okay, it technically does care about the result itself, and it sets a flag in the machine status word register. Okay. So the idea is basically whenever you're doing some sort of like comparison, like a greater than b, how do you actually figure out like whether a is greater than b or not? What you do is something like this: a minus b, and this number can be positive or non-negative, and it can be negative, right? So if it's a positive or non-negative, we know that a is actually greater than b. But if it's negative, then we know that a is actually less than b. So by doing a subtraction, we actually can make a decision whether that number is greater than or less than or anything like that. So that's what we set in the machine status word register, and these are some of them. So CF, carry flag, this is going to be set like this one indicates whether overflow for the unsigned operations happened. Okay. OF, overflow flag, indicates indicates operation caused 2's complement overflow. Whenever you're trying to do a 2's complement, if there's any sort of like overflow, this one is set. SF, sign flag, indicates operation resulted in a negative value. If it's 1, it's a negative value. If it's 0, it's a positive value. ZF, zero flag, it indicates whether the operation resulted in a 0 or not. If they are like this, then they are going to be equal to each other, right? So a minus b is actually going to be 0, and that's when the ZF is set. SF is set when a is actually less than b, because their subtraction was a minus. Overflow happens, well, I cannot think of a good example right now, but whenever you're doing some sort of like 2's complement, like let's assume we have something like 0 1 0 1, something like this, its 2's complement is going to be 1 0 1 0, and then we add a 1. Well, let's make it a 0. This is going to be okay. So let's assume the number is going to be this. If we do a 2's complement, it's going to be like this. Well, I cannot think of any example right now, but the idea is whenever you are doing 2's complement, sometimes when you keep adding 1, there's going to be 1 added over here, and there's going to be a overflow. That's when this one is set. And CF is set basically when there's a unsigned operations overflow. For our purpose, we will most commonly check these codes by using various jump instruction. You don't actually have to worry about like what they do usually. There are jump instructions for that. So what are actually jumps? So jump is basically go to any specific part of the code without worrying about anything. Like that's a vanilla jump or just jump, which will be called as JMP. This is a normal jump. It just like jumps to wherever you tell it to jump to. So I'll give a better idea, like better example later on. But the idea is like the idea of jump is it jumps to a specific part of the code. Like if it's like at line 120 or something like that, and it gets something like jump to 123, then it's going to skip everything and jump straight to 130 or whatever I just like specified. So that's how jump works. So we have something called conditional jump instructions, and they actually make use of the E flags you just saw. So let's see how they work. If it's JE, okay, this label, there are going to be labels in your code. Like these are something like names or function names or something like that. So there's going to be multiple levels, and what jump does is it just jumps to that specific level. Like wherever that level is in the code is going to jump to that part. So if if you have a level called L1 and it's in your line 123, if I write jump L1, it's going to jump to line 123. So that's how it works. So if it's JE, it's going to jump when the comparison is 0. JNE is when the comparison is non-zero. JS is when the comparison is negative. JS basically means shorter than. Well, we'll see it soon enough. JNS basically means non-negative. Like whenever it's a okay. JS is when the comparison is negative. JNS is when the comparison is non-negative. JG is when the comparison is positive. This happened. JGE is when it's non-negative, or this sign. JL is when the comparison is negative, this sign. JLE is when the comparison is non-positive, this sign. JA is above or unsigned. Like okay, so these are for signs, these are for unsigns. Okay, JA is above, JAE is equal or above, JB is below, and JBE is below or equal. These are some conditional jumps you have to keep in your head, or like you write down in your cheat sheet, but these are basically the ones we always work with. As far as I know, there's the other one, just jump, which is unconditional jump. It can jump to anywhere it wants without doing any sort of like comparison, but these ones always work based on the comparison that was done between two registers. Okay, So yeah, let's assume we have a C code like this. It's int y equal to 5 if x is greater than equal 0 y plus plus. Okay, so if we turn it into a assembly by running the command this, we get this part of assembly. What's happening is first we are putting 5 in a variable, which is this line. Then we are doing a comparison between 0 and another variable, which is x. So in this case we can map the fact that this is y and x is here, and we are doing some sort of comparison, CMP. Then we are checking if it's JS. We saw that JS basically means where is it, negative, right? So if the comparison between 0 and this x, so basically x minus 0, if the comparison is um, negative, so basically if x is less than 0, it's going to jump to L1. Otherwise it's just going to go to the next line, which is this, and then we are adding 1 to y, because we know that this was the variable y, right? So this is a very simple version of a C code and turning into a assembly code. So sometimes we, instead of checking this value, we usually check the opposite value, because that's easier to check most of the time, not always, most of the time. Okay, so in this case we just checked whether x is less than 0. We checked that it's not, like it does, like it depends on the value itself. So if it is not, then it goes here. If it is, then it goes here. Sorry, the opposite. If it is not, then it goes here. Otherwise it goes here. So the thing about jump statements are, if the condition is true, like for in this case, if j, like we are doing JS, right? So in this case, if this comparison yields something that is a negative, only then the jump is going to execute. Otherwise it's just going to go to the next line. Okay, and then it goes to the label that is specified over here. So over here L1 is here, so jump is basically jumping there. I hope that makes sense. So we can actually turn it back, like go back from the assembly to the C code. So over here we are putting something in a variable. So what we are basically doing is y equal to 5. Then we are doing some sort of comparison, right? Then we are going to go to L1 if this value is less than this value. Okay, so if x is less than 0, go to L1. Otherwise add 1 to it. So from assembly we turned it into a C code. So that's how you interchange, like you move back and forth from assembly to C and C to assembly. Okay, so let's see what happens in case of if else. So in this case we have int y equal to 5. If x is greater than 0, y is going to be incremented, otherwise it's going to be decremented. So this part of the code is pretty much the same as before. The only difference is this. Okay, so what happens is whenever, oh okay, this is also new. If you look at the previous code, we didn't have any unconditional jump. So what it does is, just like before, it checks whether this number is less than this number. If it's true, like if this one is less than this, then it's going to jump to L4, and then it's going to subtract 1 from x, sorry, from y. So this one is going to happen. So the first thing we're checking is whether it's an else statement. And then if it's not true, in that case, it's going to add 1 to y, which is this part. Then something happens. The thing is like, after this command is executed, then we should go here, right? We shouldn't be going to else. So if it normally went to the next line, it's going to do a subtraction. We do not want that. That's why we did a unconditional jump statement. So because this line was executed, the code jumped to L3 instead of doing any part of it. So that's how unconditional jump works. It doesn't care what the comparison was, it just does a jump. Okay. So once again, if we want to go back to from assembly to C, we can do that. So basically over here, we are putting a number 5 in a variable. In this case, it's y. Then we are doing a comparison with 0 and 4 if js, right? In this case, this is x. So if x is less than 0, we are going to go to L4. So y minus minus. Otherwise, we are going to do a y plus plus and jump outside. So let's see how the C code looks like. In this case, y equal to 5, just like before, checking the same thing, go to LO4, which is over here, and then do a y minus minus. Otherwise, it's going to do y plus plus and go to LO3. Okay, so something you might have noticed over here is we are using goto. Goto does exist in C, but you should not be using that. And that's why, because over here, you can just write something like go to L4 or L5 or L6, and it doesn't follow any pattern. It just goes there. Because over here, you're just like working with assembly, so you know why it matters. But if in your code you just randomly select levels to jump to, it doesn't make sense, and that's not structured programming, and that's why you are not supposed to use goto in your C. It's an option, but you shouldn't be using it. Now let's take a look at a do-while statement. So how do-while happens is like, remember, if you recall from your Java course, we have like, okay, in this course, sorry, in this part, we are just doing y equal to 0. Then what happens in do-while is it first executes the body, then it checks for the condition. If the condition is true, it goes back. Otherwise, it breaks the loop. Basically, the opposite of while loop, right? The condition is checked at the end instead of at the beginning. So let's see what happens in this code. So the first thing we're doing is we are putting 0 in y. Then we are just doing a add, because over here we added 1 to y. So we are adding 1 to y. Then we are doing subtraction, decrementing x. So subtraction 1 from x. Then we are checking for x is greater than 0 or not. So to do that check, we are doing a compare 0 against x. If it's greater than, like if the answer is greater than, so basically over here we are doing something like x minus 0, and if this statement is true, like if this statement is jg, in that case we know that it's greater than, right? So we are basically checking whether x is greater than 0. If it's true, go back to LO2, otherwise break the loop. So over here you have noticed that we are not doing a completely opposite condition. In this case, we are just using the normal one, because this one is much easier to check rather than this. So compiler basically makes this decision of like which jump statement should be used, but it always makes sure that it is actually equivalent to the version in C. Like it will never make that mistake. Only we will be making that mistake. So we can go back you like from the assembly we can go back. So over here we are doing something like y equal to 0. Over here we are doing something like y plus plus, because we are adding 1 to y. We are doing x minus minus because we are subtracting 1 from x. Then we are doing a comparison. So basically this comparison, and if it's true, like if it's greater than, so in this case if x is greater than 0, jump to LO2. So then it is go to LO2, otherwise break it. So as you can see, we have converted the whole thing into C again. Now let's take a look at how while looks. We just took a look at how do while works. Now we will take a look at how while works. Okay, so let's see what's happening here. So it's pretty much the same code as before, but the condition will be checked beforehand. Okay, so let's see how the assembly code looks like. First we are moving 0 to y, which is pretty straightforward. Then we are going to jump to LO2 directly. We are going to skip this part. Okay, then we are doing our comparison. If the statement is true, then we are going to jump to LO3 and then do the same stuff as before. So as you can see, do while, because the condition was checked later, it literally came out later in the assembly code. But like in this case, even though the condition is checked beforehand, to make more sense out of it, the comparison is done after the loop, because if you did this comparison over here, well, you could still do it. You could do a comp over here, and then you could just use like JLE and then jump to L2. So that would have still worked, but the compiler decided that this is the best way to do it. Okay, so you're not going to write assembly code directly ever, so you don't have to worry about it. But what you have to understand is how to read the assembly code in the first place. Okay, so once again, the reverse engineering, we are doing this over here. Then we are doing literally a jump over here. So we are jumping here. Then we are doing a comparison, and if the comparison is true, I keep saying that. So if this one is true, jump over here. So if it's true, go to LO3. Otherwise, just keep continue. Okay, so that's how we are converting while statements from assembly to C and C to assembly. Okay, so I am going to stop here for this video. Let this sink in, and then I'm going to show you a bigger version of a complete version of a reverse engineering in another video. I'm just trying to divide this lecture into chunk so that you have better understanding of what just happened. Like, okay, so in this lecture we basically took a look at what sort of like flags are going to be used. This is not going to be in the test, so you don't have to worry about it, but it's something you should know about. These are the list of what jump statements we have available, and then we took a look at like how if statement works, how if else statement works, and how do while works, and how while loop works. Okay, and then from the next video we'll be taking a look at like how to convert a assembly code into a C. We have been seeing something like that over here and the previous examples, and this one is going to be a more extensive version. So I'm going to stop this video here and continue in the next video.